Okay, so here we are, day 9, day before the exam, and we're going to go over chapters 11 and 12, I believe it is, concerning insulators and conductors, and then finally uh, and batteries and stuff. Uh, for insulators and conductors, basically have got a choice of different types of materials. All right. The conductors are all metallic. Okay. Metallic form of a solid is the stuff that conducts electricity because of its structure, uh, atomic structure, where the atoms come together. They stay together through a pool of free electrons. Okay, they hold them all together, and these electrons are free to move around, so you can get electricity. All right, and mainly their wires were used, or in the case of PW boards, we use what we call traces, or sometimes we call them vias. All right, basically they're a deposited tin material type of thing that conducts well and solders easily. Okay, and that's their purpose, is to be able to be solderable. Tin is a fairly decent conductor. Probably the best conductor there is probably gold. Okay, gold is about the best. Some of your really high-priced uh, connectors, for example, have a gold film over them so that they conduct extremely well. And so some of you hi-fi people will probably prefer using jacks that are gold plated. Okay, you get that extra high fidelity using that stuff. Insulators are stuff that doesn't conduct because they don't have those free electrons available when they solidify. Okay, and basically we're talking about plastics, and plastics, when they solidify, they actually are molecular in structure. So you've got these long string of molecules that form a plastic. Okay, and there are basically two types of plastics. And both of them don't conduct, and they do form some kind of insulation. All right, they don't have free electrons. The other type of conductors that we haven't discussed yet, and you will in a future course, are what we call semiconductors. Well, they should actually be called semi-insulators because they should actually be insulators, but because of the way they form and some of the internal energy, it makes it easy for them to free electrons and for them to conduct. And of course, we're talking about silicon and germanium, but also gallium arsenide, stuff that you use for light emitting diodes. Okay, those are semiconductors, and the difference between a semiconductor and a metal, an important difference, is that when you heat up a semiconductor, the resistance decreases. Whereas if you heat up a um, normal conductor, a metallic conductor, the resistance increases with temperature. There is a coefficient we call the TCE, temperature coefficient. Okay, the TC if it's positive, it means it's basically metallic and the resistance increases with temperature. But if it's a negative number, the resistance decreases with with uh, with temperature. The reason this increases decreases with temperature is because at higher temperatures you release more free electrons in a semiconductor that can perform more. They can add to your total conductivity of the material. So insulators and conductors, good insulation materials are also rubber type materials. Some of the rubber type materials are good because they are good electrical insulators, but they do have a little bit better thermal conductivity than normal insulators. So people use certain plastics and rubber type materials to get your thermal conductivity when you need to cool down components on a PW board. Okay. Then, of course, we use wires, and wires are insulated. All right, they're multi-strand wires. There are many different types of wiring, and you string a lot of wires together to form a cable. And you've got connections, an umpteen million of different types of connections you can have. But the most popular one in electronics is a two-wire insulated with a shielded metal surrounding, followed by insulation. The shield basically helps you protect against electromagnetic interference. All right. So we normally call that a twisted pair. All right. A shielded twisted pair is very important. And then finally, we're going to get into batteries. Batteries work through chemical reactions. Okay, so you require dissimilar metals, and you need a medium that's can conduct in a liquid state or a semi-liquid state. Okay, so for example, you can create a battery actually by taking a lemon, taking a copper strip and a zinc strip. The copper and the zinc like to react with one another. So if you place the strips inside the lemon, okay, you've got a positive and negative side of a battery, and that can actually give you some kind of a electrical discharge, all right, between the copper and the zinc. So there are many different types of batteries today, and the chapter goes through a number of them. Some batteries come as they are. Okay, you use them and they run out. Other batteries are rechargeable, and you can learn about that in the chapter. They have very fancy type of chemical reactions. Don't expect you to remember those reactions, but know that they are there. Okay. And finally, also, you'll find in today's thing, I have a PowerPoint on a review for the final exam, which is tomorrow, the day after. And it pretty much covers the entire 2-week session. All right, so concentrate on all of it. You really need to know most of it, okay? The exam is going to concentrate mainly on what we did this week's lessons, and I know you should just review each day's work. You've got plenty of graphics with you and other things to help you out, and get ready for Friday. So good luck.